Alright, good day students. In this clip we're going to be going over how to solve systems of equations by graphing. We're going to work with slope-intercept form first, as illustrated here, and then we'll focus on standard form. Alright, so let's do this one first. So when you say solve by graphing, we're going to graph these two lines and their intersection will be the solution. Okay, so these two lines are in the slope-intercept form. What does that mean? What is the slope-intercept form? The slope-intercept form is a form that makes the slope and the y-intercept explicit. Okay, let me write that. The slope-intercept form, you learned this in Algebra 1 and 2, is y equals mx plus what? Plus b, because it makes the slope and the y-intercept explicit. The coefficient of x is always the slope, and then the other number that you add in on, the constant you add on, is the y-intercept. Okay? So m is the slope, which is rise over run, and then b is the y-intercept. Okay? That's the y-intercept. Alright, so let's go ahead and graph these two lines. Okay? So let me label them line 1 and 2. Okay, so let's start with line 1. So with line 1, the slope is the coefficient of x, 1 over 4. What does that mean? It means you're going to rise 1, and then you're going to run 4. Where do you start from? You're going to start from b, the y-intercept. B is -2. So starting from -2 on the y, we're going to go up 1 and over 4 to get the second point. Remember from geometry, 2 points determine a line. Okay? So everybody mark your starting point. Your starting point is always your y-intercept. So mark -2 on your y-axis. Now from there, we need the second point to define our line. So we're going to rise 1 and run 1, 2, 3, 4. Boom. There goes the 2 points that define line 1. Alright, so let's draw the graph of line 1. Oh, it's going to look something like that. We're going to constrain our line to the coordinate grid. And then we also have to put arrows at the ends. Alright, so make sure your lines are perfectly straight. So that goes line 1. Now let's take a look at line 2. For line 2, m is 5 over 4. What does that mean? It means you're going to go up 5 and over 4. Where are we starting from? The y-intercept is 2, so we're going to start from 2 on the y-axis. So starting from 2 on the y-axis, we're going to go up 5 and over 4. So I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So going up and over takes me out of the graph. So I can do the exact opposite. So either going up and over, or I can go down and back. Going up and over, the opposite down and back is the same thing. So I can go down 1, 2, 3, 4, 5, and back 1, 2, 3, 4. You see that? So it's the same thing. So anytime you end up going out the graph, you can do the exact opposite of that. Alright, so instead of going up and over, you can go down and back. You are going to fall on exactly the same line. Alright, so these 2 points determine line 2. So you use straight line, you get through there. Our line has to cover the whole coordinate system, like that. And then there goes your solution. Alright, so what is our solution? The solution is the coordinates of the intersection. So the solution is, for the x coordinate, -4, for the y coordinate, -3. So there you have it. Now I need you to check. Okay, you need to check to make sure your answers are correct. You're required to do this for all the problems. So we're going to do a check. Alright? So the check is as follows. For the first equation, for 1, we're going to do, this is x and this is y, so we're going to plug these into the first equation to see if it works. So the question is -3 equal to 1 over 4 times -4 minus 2. Is that right? So I plugged in these two into the first one, and yeah, the question is, does it work out? If it does, then we'll text the second one. So I just leave the left side alone, and on the right side I times it out. This becomes -1 minus 2. And is -3 equal -3? Yes, so it checks out. Okay? So that works nicely. But there are two equations that this point must satisfy in order for our answer to be accurate. Okay? But the first one has been satisfied. Now the second one, the question is let me deviate off the center so we don't get confused. The second one is -3, one color, is -3 equals 5/4 times -4 plus 2. Is it? I plugged in these two into that to see if it works out. So the question is -3. If I times this out, this one and this one cancels out, right? So we're going to have -5, because we left with a 1 here, plus 2. So is -3 equal -3? Is it? Yes, so it checks out. So our answer is accurate. Okay? You always have to do a check for these problems. Alright, so now let's take a look at a situation where our equations are provided in standard form. Alright? Okay, so let's take a look at that scenario. Number 13 satisfies this requirement. See, they're both in standard form, x and y is on the same side. So, for these, I like to put them in a slope-intercept form so I can graph them with ease, okay? So let's label them 1 and 2. Let's start with 1. So from 1, we have x minus 3y equals 9. So I want to get y by itself, right? So move the x first and then get rid of the -3. So how do you move the x? Subtract x from both sides. So you're going to end up with -3y equals -x plus 9. Now we're going to divide everything by -3 so y stands alone. Okay, so divide this by -3, divide that by -3, and divide that by -3. So you're going to end up with y equals, minus over minus is positive, so we can write this as 1/3x plus over minus is negative, so -3. So that's for line 1. So for line 1, the slope is 1/3, which means we're going to rise 1 and run 3, starting from -3. Alright, so let's go ahead and graph line 1. So we're going to start from -3, rise 1, and then run 1, 2, 3. So there. Okay? So there goes the first one, and then we'll draw our line. Straight line through the 2 points. Alright. Okay. Now let's move on to the second line. Okay? Second line is also in standard form, so we need to transform the equation into slope-intercept form. So for 2, we're going to have is 2x minus y equals -2. That's what we have. So let's put it in standard form. So to do that, what we do is try to get y by itself. So first thing we do is get rid of 2x, subtract 2x from both sides. And then we're going to have -y equals -2x minus 2. But this minus here is a problem. How do I get rid of this minus? I need to divide everything by what? -1, every single thing. So divide this by -1, divide this by -1, and divide that by -1. Alternatively, you can switch out the signs. So if I divide everything by -1, I'm going to end up with y equals 2x plus 2. Alright. So m, the slope is going to be 2 over 1. Coefficient of x, which means we rise 2 and run 1. And then your y-intercept is 2. That's where you start from on the y-axis. So starting from 2, on the y-axis, you're going to rise 1, 2, and run 1. That gives us our line. Okay. So, and then we're going to draw a line from there. Alright, so let's go ahead and graph it. So we're going to start from 2 and go up to over 2 over 1. So let's go ahead and graph the line. I can put in more points if I wanted to. So up 2 over 1, or I can go down 2 back 1. Back 1, down 2 back 1, down 2 back 1. Takes me right here. So I can draw my line. You can see it goes perfectly through all these lines right here. Okay. So there goes your final result. So what is our solution going to be? The intersection will be the solution, right? So there goes the intersection. Coordinates of the intersection is -3, ooh. Yeah, -3, -4. So there's a solution. So solution is -3, -4. Alright, so the question now is our answer correct? Well, we have to do a check. We have to verify that this ordered pair satisfies both equations. Alright? So we're gonna test equation 1 and equation 1 and equation 2. So let's start out by trying equation 1. So equation 1 is x minus 3, y equals 9. So let's test this 2 and see if it works here. So the question is -3 minus 3 times -4 equals 9? Is it? Is -3 plus 12 equals 9? Is 9 equal 9? Yes, that checks out. Alright, let's test our second equation, equation number 2. Which is 2x minus y equals -2. So the question is 2 times -3 minus -4, is it equal to -2? I basically substituted these two into my x and y values, and I'm going to compute them to see if I get the right side. So the question is -6 plus 4, because minus times minus is plus, right? Is equal to -2? Is -2 equal -2? It is, so it checks out. So our answer is correct. Okay? So that's how you do a problem like this. I need you to do a check for all the problems you solve by graphing. Alright, so we're going to go ahead and start on the first part of the classwork. Alright, welcome back, students. Now we're going to work on solving systems using a different method, namely elimination. We're going to work on the elementary parts, on the elementary types of problems today, and then we'll do the more involved problems next class, okay? So, solve by elimination. Whenever you see the word elimination, the first thing that should come up into your mind is the whole idea of opposites, okay? What do opposites do in math? Opposites cancel each other out. Okay, if you have opposites, they cancel out. So let's take a look at number 23. This is equation 1, and this is equation 2. Let's take a look at it closely first. Do we see any opposites here? Do we see any opposites here? So when I say opposites, you look at the x's and then the y's and ask yourself, are the x's opposites or are the y's opposites? So what I'm asking is, what's the opposite of -8? 8, right? Is this 8? No, so the x's are not opposites. How about y's? What's the opposite of -5? 5. +5. So the y's are opposites. So if you have opposites, all you simply do is just combine the two equations. Straight down. Alright, why do I combine it? Because when I combine it on this side, I'll get x. But guess what happens here? The y's cancel out. You get what? Eliminated. So that's going to be x equals 2. Alright, so there's our x solution. So now we're going to plug in the 2 into any one of these two to get our y. So we're going to substitute 2 for x, either on the first one or on the second one. The easiest one to do is the one that has no number in front of y. But they both have numbers in front of y, so it doesn't really matter the one we pick. So I'm going to substitute 2 for y in 2 because it's positive. Alright, I'd rather go for positive rather than the negative. Okay, so you're going to go 9 times 2 plus 5y equals 28. So how do you do this? Times it, 18. 9 times 2 is 18, plus 5y equals 28. Okay? Subtract 18 from both sides, and you have 5y equals 10. Divide both sides by 5, and you end up with y equals 2. Alright? So our solution is basically 2 comma 2. So is this right? We have to do a check. Alright, so let's check. So to do the check, we're going to go, is negative 8 times 2. That's for the first one. Is negative 8 times 2 minus 5 times 2, negative 26. Is it? So if I work this out, this becomes negative 16. Is negative 16 minus 10 equal negative 26? Is negative 26 equal negative 26? Yes, so it checks out. Alright. Number 2 is 9 times 2 plus 5 times 2 equals 28, is it? If I times it out, is 18 plus 10 equals 28? Is 28 equal 28? The answer is yes, so it checks out. So our answer is correct because it satisfied both equations. Okay, both equations, or the system of equations, were satisfied by that. So it checks out. The answer is correct. Alright, so we're going to apply this rule in trying out some of the classwork problems for today. So thanks for listening to this clip. Remember, it's uploaded on YouTube, but you can always watch it over and over again.